So my code for the uninformed heuristic search basically relies a lot on this struct node. You could even say that it's built around it. It's built around the struct node here. The struct node has a transform info. I'm using it to get position. It has a pointer to the next or reference to the next. It's a list, so it can have a lot of children. And then prev, it has the best previous, which there is a function that will update it to find the best previous. And then the heuristic value is basically the distance the from node to destination, and I am computing it using a function from a library. But even without this function, there are many ways to search for the distance. So whether or not there was a reference did not matter. It just made things a lot simpler. And for the start, this is the start of part 2. If I set this part, there it's part 2. This is setting up the nodes. Basically, it's mapping the areas to their heuristic values and it's instantiating them and adding them to the node list, to this list of nodes here, which is basically node list here, this list of nodes. And then after setting up the nodes, I then start connecting them, and there also exists the concept of null node, from which will come the initial node. So the initial node's previous is a null node, basically. Since structs didn't accept null, I had to think up of a crafty way to do it. And then this is connect node takes a node, a previous, and then a last, and then a next. It will assign the current previous to the node to the previous parameter, and then it will add the next parameter to its list of children nodes. And then I manually set it up. I comment this as stuff where it went wrong. I have not yet deleted parts of that code. And then I perform the A-star search, which technically it is A-star, but it did not, I did not implement the concept of queue. Instead, it's similar to it's actually a breadth first search, where what happens is for every child of a node, if the current assigned previous has a higher score than your edge weight plus the heuristic value, if the current previous of next its heuristic value plus the weight of the edge to that node is bigger than your combined values, then the specific node you will replace the current previous, because it prioritizes lower scores. Basically lower scores better, because that indicates near. And then every time it finds a node score less than the current that one. That's basically what I explained. And then for each node, you iterate through a node list. Every smallest heuristic value, you assign that as the final node. So when you iterate through the loop successfully, the node with a 0 heuristic value will be your final node, because technically the destination's heuristic value to itself is 0. And then once the final node is assigned, it constructs a path using the final node, which I call here after the star search here, and I pass final node. And then it tracks the previouses. While the previous is not equal to null node, it will add it to the path of it'll add it to the total path. And then it traverses, this is how it traverses to the path in update. It'll go to from the start, it'll go to the next one. When its position is equal to the next one, it'll increase pointer, which is a global variable basically in C#. Basically, it's a global variable p plus plus, and while total path index of p plus 1 is not equal to null, it will plus plus.